Hello everyone, welcome back to lesson 3 of Pre-Algebra. So in our last lesson, we talked about 3 arithmetic properties: the associative and commutative property of multiplication and distributive property. In today's lesson, we're going to look at the properties of divisions. And in particular, we're going to introduce the concept of reciprocals, its operations, and when combined with the arithmetic properties we learned from last lesson, how they can help us solve some challenging problems faster and easier involving reciprocals. Okay, so let's get started. So before we dive into the concept of a reciprocal, let's do a quick review on division. So you've learned from your school or previous math class that division is basically the operation of a fair sharing. Now you may ask, what is fair sharing? So fair sharing is dividing a whole item into multiple parts where each part has the same amount. So the sharing amongst each part is equal and fair. So in this example, 12 divided by 3. 12 is separated into 3 parts, and each part gets 4. So take a look at the different representations here. A division can be represented as 12 divided by 3, 12 slash 3, 12 over 3, and they all equal to 4. Okay. Now if we generalize this example and let A and B represent any number, okay, so A divided by B can be represented in these ways. Okay. So in here, A is called a dividend, and B is called a divisor. Okay. And then C is called a quotient. Okay, so all of these you already know from your previous math class. Okay. So note here that although we said B represent any number, but B cannot be 0. Why? Because B is a divisor. Okay, 0 cannot be a divisor because 0 is not divisible. Okay. So let's review some special cases of division. And let's again let A be any numbers. Okay. So 0 divided by any non-zero number is always 0. Okay. And A here cannot be 0 because it's a divisor, and divisor cannot be 0. Okay. And any number divided by 1 is always a number itself. Okay. And any number divided by itself is always equal to 1. Okay. So again here it has to be a non-zero number. And finally, 1 divided by any non-zero number A is equal to 1 over A. So toward the end of this lesson, we have a brain teaser problem on long division. If you're interested and wanted to give yourself a little challenge, you can find it at the very end. Now let's introduce the concept of reciprocal. So let A represent any non-zero number. Its reciprocal is 1 divided by A. So let's take a look again. For any non-zero number A, its reciprocal is 1 divided by A. So the product of a non-zero number and its reciprocal is always 1. And that is the definition of reciprocal. Okay? So let me repeat that. The product of a non-zero number and its reciprocal is always 1. Okay? Next, let's look at a few examples and use the concept we just learned on reciprocals and apply it into our calculations. Okay? So as a reminder, the definition of reciprocal says for any non-zero number A multiplied by its reciprocal is always equal to 1. Okay? So let's keep that in mind. Now let's take a look at this problem. Evaluate the product of 2 times 3 and 1/2 times 1/3. Okay. So let's first turn this sentence into a math expression. So the product of 2 times 3 and 1/2 times 1/3. Okay. And let's use the commutative property we learned from our last lecture and then move things around a bit. So we want to move 2 and 1/2 together. Then 3 and 1/3 together, right next to each other. So next, let's use associative properties of multiplication and do a little grouping here. So I want to group 2 and 1/2 together. Then I want to group 3 and 1/3 together. Okay. So why do I group that this way? If you look at it, 2 times 1/2. Okay. So that is literally the definition of reciprocal, which gives us 1. And similarly, 3 times 1/3, which is also the definition of the reciprocal, which also gives us 1. So the end result is 1. Now pause the video and try to practice and solve this problem yourself first. Keep in mind of the reciprocal concept that we just learned. So the problem said, evaluate the product of any non-zero number a and twice its reciprocal. Okay. So the first thing we need to do is to turn this sentence into a math expression. Okay. So it says any non-zero number a, we want to find the product of twice its reciprocal. So the reciprocal of a is 1 over a. So this is the math expression that we need to simplify. So let's first use commutative properties of multiplication, and we're going to switch the order of a and 2. Okay. So it becomes 2 times a times 1 over a. Okay. So next, we're going to use associative property of multiplication and group a and 1 over a together to compute that first. So it becomes 2 times parentheses a times 1 over a. And why we group them together? So you might already see the reason. That's because any non-zero number multiplied by its reciprocal is always equal to 1. So the answer is 2. Okay, so let's recap. So we first used the commutative property here. And then we used the associative property here. And then in this step here, we use the concept of reciprocal to help us calculate. Okay. Let's look at another practice problem. Pause the videos and try to solve this problem yourself first. Think about the reciprocal definitions and try to apply it into your problem-solving steps in this problem here. So we said that for any non-zero number multiplied by its reciprocal is always equal to 1. Okay. So this problem wants us to evaluate the product of 3 numbers, 2, 3, 4, multiplied by the sum of their reciprocals. So let's first turn this sentence into a math expression. So it becomes the product of 2, 3, and 4 multiplied by the sum of their reciprocals. So the reciprocal of 2 is 1/2 plus reciprocal of 3 is 1/3 plus reciprocal of 4 is 1/4. So this is the math expression we're trying to evaluate. Now next, take a look at this expression here. So 2, 3, and 4, we can treat it as one term, and this one term is being multiplied to the sum of 3 reciprocals. So if we use distributive property, we're going to distribute this one term into each reciprocals inside this right parentheses. So this becomes 2 times 3 times 4 distributed onto the first term, which is 1/2, plus 2 times 3 times 4 distributed onto the second term, which is 1/3, plus 2 times 3 times 4 distributed onto the third element, which is 1/4. So in the next step here, we're going to use the commutative property of multiplication and move the 1/2 next to the 2 in this multiplication term, move the 1/3 next to the 3, and move the 1/4 next to the 4, which it already is in order. Okay? So this becomes 2 times 1/2 times 3 times 4 plus 2 times 3 times 1/3 times 4 plus 2 times 3 times 4 times 1/4. Now next, we're going to use associative property. We're going to group the 2 and 1/2 together to evaluate that first. We're going to group 3 and 1/3 together to evaluate that first. And we're going to group 4 and 1/4 together to evaluate that first. So this becomes parentheses 2 times 1/2 times 3 times 4 plus 2 times parentheses 3 times 1/3 parentheses times 4 plus 2 times 3 times 4 times 1/4 close parentheses. Okay. Now, why do we do such grouping? You probably already saw that. It's because we can use the definition of reciprocals here, that 2 and 1/2 are reciprocals of each other, so that becomes a 1. And it becomes 1 times 3 times 4 plus 2 times, similarly, 3 times 1/3 is also equal to 1 because they're reciprocal of each other, times 4 plus 2 times 3 times 4 times 1/4 are reciprocal of each other and they're equal to 1. Okay, so this becomes 12 plus 8 plus 6. And the final answer is 26. So let's do a quick recap here. In this step here, we use the distributive property. And in this step here, we use the commutative property of multiplication. And in the next step here, we use the associative property of multiplication. And in here, we apply the definition of reciprocal. Okay? So the final answer is 26. So we learned that the reciprocal of a non-zero number a is equal to 1 over a. So what about the reciprocal of a number times the reciprocal of another number? So the reciprocal of x times the reciprocal of y is equal to the reciprocal of x times y. Okay? So let's look at a few examples to help us get familiarized with this property. So from the previous screen, we said that if we let x and y be any non-zero numbers, then the reciprocal of x multiplied by the reciprocal of y is equal to the reciprocal of x times y. Okay, so let's keep this in mind. Okay. So let's look at this problem. Let x equal to 32 and y equal to 30. Evaluate the product of their reciprocals. So the first thing we always do is we turn this sentence into a math expression before we simplify it. Okay. So it says evaluate the product of the reciprocals. The reciprocal of x is 1 over x, which is 1 over 32. The reciprocal of y is 1 over 30. And we want to get the product of these two. Okay. So we know that from this property here, this is equal to 1 over the product of 32 and 30. And this whole thing gives us 1 over 960. Okay. This is a similar problem with the example we just discussed. So pause the videos and try to solve this problem yourself first. So keep in mind that we said for x and y be non-zero numbers, the reciprocal of x times the reciprocal of y is equal to the reciprocal of x times y. Okay. So in this practice problem, instead of two numbers, we have three numbers. Okay. So let x equal to 32, y is 30, and z is 10. Evaluate the product of their reciprocals. So let's turn this into a math expression. So we first need to find out the reciprocal of each one. So x becomes 1 over 32, reciprocal of y is 1 over 30, and reciprocal of z is 1 over 10. Okay, so this is the expression. Now we're going to use this to help us compute the problem. So this becomes 1 over 32 times 30 times 10. It's the product of all three numbers and the reciprocal of that. Okay. So this essentially gives us 960 times 10, which is 9,600. So we learned that the reciprocal of a non-zero number a is 1 over 8. Then what about the reciprocal of 1 over 8? What does that equal to? So let's try this question out first with using some actual real numbers. Let's use 1 over 8 as an example. And we're going to treat this 1 over 8 as a whole thing. Okay. The reciprocal of this whole thing is 1 over this whole thing. And this whole thing is 1 over the number 8. So it becomes 1 over 1 over 8. And if we evaluate this, the number is 8. So the reciprocal of 1 over 8 is actually 8. Let's look at another example. 1 over 100. Similarly, we're going to treat 1 over 100 as a whole thing. The reciprocal of this whole thing is 1 over this whole thing. And this whole thing is 1 over 100. So it becomes 1 over 1 over 100. And this gets evaluated to 100. Okay. So the reciprocal of 1 over 100 is 100. Now if we generalize the number 8 and 100 using the letter A, it becomes the reciprocal of any non-zero number. 1 over 8 is equal to 8. So similarly, the reciprocal of the product of two non-zero numbers is equal to the product of the numbers. Okay, so 1 over 8 times b is equal to 8 times b. So you might actually already see this pattern that the reciprocal of reciprocal is the number itself. Okay, so applying the reciprocal twice on the number is the number itself. So if this is still confusing to you a little bit, let's take it slowly and look again. So we're going to apply reciprocal twice on a non-zero number a. So applying the first time, reciprocal of a is 1 over a. Now applying the reciprocal second time on 1 over a gives back a, which is what we looked at here. Okay. So we started with a, applied the reciprocal once, twice, and we got a back as the final result. So taking a real number as an example, reciprocal of the number 8 is 1 over 8. We know that from previously. And now applying the reciprocal the second time on 1 over 8. So the reciprocal of 1 over 8 is the number 8. Okay? So we started with 8, apply the reciprocal once, twice, and we get the number 8 itself back again. So far what we have looked at is centered around given a non-zero number, its reciprocal is 1 divided by this number, and vice versa. We also know that a number multiplied by its reciprocal is always equal to 1. So here we're going to look at how we can use reciprocal to convert a division problem into a multiplication problem. Therefore, all the arithmetic properties of multiplication we learned in the previous lesson can be applied. And this makes reciprocal very powerful in our calculations. So how to convert a division into multiplication? If there are two numbers, a and b being non-zero, a divided by b is the same as a multiplied by b's reciprocal. So here, a divided by b becomes a times 1 over b. So before we move on to tackle a few problems using this expression, let's try to understand it better using some illustrations to demonstrate how we can actually turn a division into a multiplication. So we learned that a divided by b was non-zero is the same as a multiplied by 1 over b. So let's say that we have a is 1 and b is 2. So we have 1 divided by 2, which is equivalent of 1 multiplied by 2's reciprocal, which is 1/2. Let's use a square with an area of 1 to represent the 1 in this expression. Okay. So a square with area of 1, each side has a length of 1. Now we're going to divide it into half. Okay. That means this segment gets a half, and this segment also gets a half. So a square with area of 1 divided into 2, then 1 unit is this little rectangle with a length of 1 and the height of 1/2. And the area of this rectangle is 1 multiplied by 1/2, which is 1/2. So you see we started with 1 divided by 2, and that is the equivalent of 1 multiplied by 2's reciprocal, which is 1/2. Now instead of 1 divided by 2, let's try 1 divided by 3. This becomes 1 multiplied by 3's reciprocal, which is 1/3. So same thing, we're going to use a square with an area of 1 to represent the 1 in this expression. Each side has a length of 1. This time, we're going to divide it into 3 parts. Okay. So this segment becomes 1/3, and this segment is 1/3, and this segment is also 1/3. Okay. So 1 square divided into 3, then one section becomes 1 over 1/3. And the area of this unit section becomes 1 times 1/3, which is 1/3. So we started with 1 divided by 3, and we ended up with 1 multiplied by 3's reciprocal. So instead of 1's, 2's, and 3's, we can generalize this with a divided by b. And using the same derivation methodologies, you will eventually get the same thing, that a divided by b is the same as a times 1 over b. So let's take a look at our first example of how we can use reciprocal to turn a division problem into a multiplication problem. So we have 2 times 3 times 5 divided by 1/2 times 1/3. So let's evaluate the parentheses first. 2 times 3 times 5 is 6 times 5, which is 30. Divided by 1/2 times 1/3 is 1 over 2 times 3. And this is essentially 30 divided by 1 over 6. So 30 divided by 1 over 6 is the same as 30 multiplied by the reciprocal of 1 over 6. And the reciprocal of 1 over 6 we learned from earlier is 6. So the answer to this problem is 180. So in this problem here, we're going to first use reciprocals to convert division into multiplication. And then we're going to use the commutative property of multiplication to help us solve the problem. So let's take a look. A divided by 1/3 divided by 125. This is the equivalent as 8 multiplied by the reciprocal of 1/3, which is 3 multiplied by the reciprocal of 125, which is 125. Now next we use commutative properties to switch the order of 3 and 125. So this becomes 8 multiplied by 125 multiplied by 3. And we all know 8 times 125 is equal to 1000 multiplied by 3, and the final answer is 3000. In this example, we're going to use the same methodology. We first use reciprocal to turn all of these divisions into multiplications, and then we're going to use associative property of multiplications to help us solve the problem. So this becomes 1024 multiplied by the reciprocal of 2, which is 1/2. And we do this on all of them, and there are 9 of them total. In the next step, we're going to group all of these 1/2 together using associative properties and compute that first. So this becomes 1024 multiplied by 1 over 2 times itself 9 times. Okay? And 2 times itself 9 times is equal to 512. So it becomes 1024 times 1 over 512. This is essentially 1024 over 512, and the answer is 2. Okay, so in this third example, we're going to first use the same methodology, convert this division into a multiplication, and then we're going to use distributive property to solve it. So it becomes 12 plus 48 plus 63 multiplied by the reciprocal of 3 is 1/3. In the next step, we're going to distribute this 1/3 into each term inside the parentheses. So it becomes 12 times 1/3 plus 48 times 1/3 plus 63 times 1/3. This becomes 12 times 1/3 is 4 plus 48 times 1/3 is 16 plus 63 times 1/3 is 21. So the final answer is 4 plus 16 is 20. 20 plus 21 is 41. Now try to solve this practice problem using all of the techniques we used in the previous 3 examples. So pause the video and try solving yourself first. In this problem, the very first thing we're going to do is to convert this division into a multiplication. So let's copy down first everything in the front. It's 20 times 24 times 28 times 32. Now we're going to treat everything inside this parentheses as one whole term. So dividing by this one whole term is the equivalent of multiplying its reciprocal, which is 1 over this one whole term, which is 10 times 12 times 14 times 16. So we talked about earlier that if we let x and y be any non-zero number, okay, then the product of their reciprocal is equal to the reciprocal of their product. So in here, we have a reciprocal of product, and we can rewrite this as a product of reciprocals. So this becomes 20 times 24 times 28 times 32 times 1 over 10 times 1 over 12 times 1 over 14 times 1 over 16. In our next step, we're going to use commutative property of multiplication and move things around a bit. So we're going to first move this 1 over 10 right next to 20. So it becomes 20 multiplied by 1 over 10 and multiplied by 24. Then we're going to move the 1 over 12 next to the 24. So it becomes multiplied by 1 over 12. And then 28 multiplied by, we're going to move the 1 over 14 next to it. So it becomes 1 over 14 times this term here, 32 multiplied by the last term, 1 over 16. Okay, in our next step, we're going to use associative property, and we're going to group 20 and 1 over 10 together, 24 and 1 over 12 together, and so on and so forth for the next two terms. So it becomes 20 times 1 over 10 times, we're going to group 24 and 1 over 12 together, times grouping 28 and 1 over 14 together, times 32 times 1 over 16 grouped together. Okay? So now you can see the first parentheses evaluated becomes 2. The second one evaluated also 2. The third parentheses evaluated equals to 2. And the last one evaluated is again 2. So we have 2 times 2 times 2 times 2. So the answer is 16. So let's take a recap of the steps we did. So in this first step here, we used reciprocal to turn a division into a multiplication. Now in this second step, we used the reciprocal that its product is equal to the reciprocal of each one. Okay? In this third step, we use the commutative property of multiplication. And in this next step, we use the associative property of multiplication. And the final answer is 16. So far we did a handful of examples and practice problems on converting division into multiplication using reciprocals. Now let's look at one more method to convert division into multiplication. So in the expression containing multiplications and divisions, when we insert a pair of parentheses into an expression that has a division sign in front of it, then we change all the inside multiplications into division and divisions into multiplications. Okay, this can probably sound very abstract to you. Let's look at a few example problems to illustrate and understand this. So earlier, if you remember, we solved this problem by using reciprocals to convert the divisions into multiplications. So what we did was we started with 1024. Instead of divide by 2, we multiplied by its reciprocal. And we did that for each term. And there are 9 total. So there are 9 of these here. So in our next step, what we did is we used the associative property and we grouped all the 1/2s together. So same idea, there are 9 of them grouped together. So here inside the parentheses, we know that the product of a bunch of reciprocals is equal to the reciprocal of the product. So the expression can be rewritten as 1024 multiplied by 1 over the product, which is 2 times 2 times 2, 9 times. Okay. So we know that 2 times itself 9 times is 512. So it becomes 1024 multiplied by 1 over 512. So from here, multiplied a number's reciprocal is the same as dividing that number. So we can rewrite this as 1024 divided by 512. And the answer is 2. Now let's try to solve this again using a different method that we just talked about. We want to group all the 2's together by putting the parentheses around them. Now the place where we're inserting the parentheses has a divide sign in front of it. So that means after grouping, all the divide inside this parentheses needs to be converted into multiplication. So what we have is 1024 divided by 2. Instead of divide by 2, we need to turn it into a multiplication. So it becomes 2 times 2 times 2, and we do this for all of them 9 times. So this becomes 1024 divided by 2 times itself 9 times is 512. And the answer is 2, which is identical with what we have here. So let's take a look at one more example. And again, we're going to use 2 different methods to solve it so we can cross-compare how difficult and easy each method is. In our first method, we're going to use reciprocals to convert the divisions into multiplication. So same as before, 2,160 divided by 256 is the same as multiplying its reciprocal. Then we have multiplied by 128 and divided by 54 is the same as multiplying its reciprocal. So next, we're going to use commutative property and move things around a bit. So we're going to place the 1 over 54 right next to 2,160. Then we have 128, and we're going to place 1 over 256 last. Okay. So here, multiply by 54's reciprocal is the same as divide by 54. So we have 2,160 divided by 54 multiplied by 128. Same here, multiplied by 256's reciprocal is the same as divided by 256. Okay. So if you work out your long division on the first 2 terms, this will give you 40. Okay. Then we have multiplied by 128 divided by 256. Okay. So if we work out your multiplication verticals, 40 times 128 will give you 5,120. Then divided by 256. And if we work out our long divisions again, these 2 terms will give you the final answer of 20. So in this method, we had to do several cumbersome calculations using long divisions and multiplication verticals. Let's try a second method. We're going to use grouping and group 256, 120, and 54 together by putting them inside the parentheses. Now the place where we're inserting the parentheses has a divide sign in front of it. So we said that if there's a division sign in front of the parentheses, then after grouping, all the signs inside the parentheses needs to be reversed. So let's take a look. We start with 2,160 divided by we're going to add the parentheses to group them. 256. Then instead of multiplication, this becomes a division. Divided by 128. And instead of division, it will become multiplication. So multiplied by 54. Okay. So this becomes 2,160 divided by, now 256 is twice of 128. So the first two terms will give you 2 times 54. Okay. So 2,160 divided by 2 times 54 is 108. And if you work out your long division, the answer to this is also 20. Okay. So what we did is we started with the same problem. We got the same result, which both are 20, but with two different methods. And you can see that how one method here involves less cumbersome calculations compared to this one right here. So this pretty much concludes our lecture for today. So what we have talked about today is we looked at what is reciprocals, its definitions, and we also looked at how we can use reciprocals to convert division into multiplications so that all the arithmetic properties of multiplications we learned from earlier lesson can be used. We also looked at one more method of converting division into multiplications by using grouping instead of using reciprocals. So as promised earlier, this is the brain teaser problem on long division. Pause the video and give this problem a try yourself. The solution is posted coming up next. Let's take a look at the solution to this question. The question says, if each star represents an unknown digit and none of the digit in the divisor appears again in the problem, what is the value of the quotient? So let's list out all of our digits first. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay. Now let's take a look at this first digit in the quotient. Okay. We know that the first digit of quotient cannot be any number in the divisor. So 1, 3, and 5 is immediately eliminated. Okay. We also know that the first quotient cannot be 0. So this is also eliminated. Now, it cannot be 7 and 9 either, because any odd number multiplied by 5 will terminate with 5. So the 5 here will be duplicated with the 5 in the divisor. So 7 and 9 are eliminated. Okay. So let's look at 8. If this first digit in the quotient is 8, 8 times 135 will give you a number that is 4-digit, which is too big. Okay, so that is also eliminated. So we're left with 2, 4, and 6. Okay, so now let's try 6. We're going to apply the 6 onto 135 first. So it becomes 135 times 6. And this gives you 810. Now this 1 is duplicated with the 1 in the divisor. So 6 is eliminated. Now what about 4? So if we put 4 here, it becomes 135 times 4. And this is 540. Okay, this 5 here is also duplicated with the 5 in the divisor. So 4 is also eliminated. So the only digit left is 2. So the first digit in the quotient is a 2. Now let's look at the second digit in the quotient. So we're again going to list out all of our digits, and we're going to use the same elimination method. Okay. So 1, 3, 5 are numbers in the divisor. They cannot appear again. Okay. And we know 7 and 9 cannot be it because they're all number multiplied by 5 will result in the 5 here, which is a duplicate. So they're gone. And 8, we also know that 8 times 135 is a 4-digit number. It's too large. So that's also gone. Okay, so we have 2, 4, 6, and 0. 6, we know that 6 times 135 is 810. It has a 1, that's a duplicate. So that's gone. We also looked at 4. 4 times 135 results in the 5, that's a duplicate. So that's also gone. So we're left with 0 and 2. Now if we put a 0 here, 0 times 135 is 0. So the long division will actually end here instead of here. So we know 0 is also not an answer. So we're again left with 2 on the second digit. Okay. So the final answer to this question is 2,970 divided by 135, which is equal to 22. Okay. So hopefully you had fun with this practice. And this concludes all of our lectures for today. We'll see you next time.